Hello everyone and welcome to this video on inverse functions. Now if you have not watched the previous videos in the function series, please do so by clicking on the link in the description below. The information will definitely guide you in understanding the topic of this video. So what is an inverse function? Well, we know that a function transforms the object into the image. So in this case, function f transforms object x into image y. So an inverse function basically does the opposite. It transforms the image of the function back into the object. So in this case, function f inverse takes y as its object and transforms it back into the image x. It is important to note that only one-to-one relations can have inverse functions. In the case of many-to-one relations, the inverse function will have more than one image, therefore disqualifying it as a function. Here are a few important rules to take note of. The first rule is that the law of indices does not apply to inverse functions, so f inverse does not equals to 1 over f. The second rule is that composite function f inverse x, is always equals to f inverse fx. Let's take a look at how to find the inverse function from a given function. In this example, we are given the function fx is equals to 8x plus 4. So determine the inverse function f inverse. So the first step of this problem is to let fx is equals to y and f inverse y is equals to x. Now we are already given the value of fx and fx is equals to y. So y is equals to 8x plus 4. Now rewrite the equation in terms of x. So we get 8x is equals to y minus 4. So x is equals to y minus 4 over 8. Now we already know that f inverse y is equals to x. Therefore, f inverse y is equals to y minus 4 over 8. So replace y with x and we get f inverse x is equals to x minus 4 over 8. Now let's find the function when given the inverse function. In this question, it is given that f inverse x is equals to x minus 5 over 2. Find the function f. So repeat the first step like in the previous question. Now substitute object y into function f inverse and we get y minus 5 over 2 is equals to x. Now rewrite the equation in terms of y. So we get y minus 5 is equals to 2x. That gives us y is equals to 2x plus 5. Now we know that function fx is equals to y. Therefore, function fx is equals to 2x plus 5. Now let's take a look at a more complex problem which combines both composite functions and inverse functions. The question states that function fx is equals to p plus qx. P and q are constants and q is less than 0. We are also given composite function f squared x is equals to 9x minus 10. So we have to find the value of p and q and the value of f inverse squared x. Now, in order to find the value of p and q, we first need to find the value of the composite function f squared based on the given function value fx. After that, we need to compare the value of the composite function that we have found with the value of the given composite function. So let's first find the value of composite function f squared. Make function f the object of function f. Then substitute the value of fx into the equation and we get function f with object p plus qx. Then substitute object p plus qx into function f. After doing so, compare this composite function value to the given composite function. So that gives us p plus q, open bracket, p plus qx, close bracket, equals to 9x minus 10. So after simplifying, we get p plus pq plus q squared x equals to 9x minus 10. Now, in order to find the value of p and q, we need to rearrange the equation so that all the x terms are on the left and all the constants are on the right. Now we have to compare like terms with each other. So in this case, q squared x is equals to 9x. So take the coefficient of x for both values, so we get q squared equals to 9. So that means q equals to 3 or negative 3. But we already know that q is less than 0, so q has to be negative 3. Next, compare the constant values. So we get p plus pq is equals to negative 10. Now we already know the value of q, so let's substitute that into the equation and we get p plus p multiplied by negative 3 is equals to negative 10. That gives us negative 2p is equals to negative 10. So p is equals to 5. Part B involves inverse functions. So the first step is to let f(x) is equals to y and f inverse y is equals to x. Since we already know the value of f(x) and f(x) is equals to y, we can write y equals to 5 plus 3x. So rewrite the equation in terms of x and we get 3x is equals to 5 minus y and x equals to 5 minus y over 3. Therefore, f inverse y is equals to 5 minus y over 3. Now replace y with x and we get f inverse x equals to 5 minus x over 3. Now expand function f inverse square x and we get function f inverse x. Now substitute f inverse x into the equation and we get f inverse with object 5 minus x over 3. Now put object 5 minus x over 3 into function f inverse and we get 5 minus open bracket 5 minus x over 3 close bracket over 3. Now rewrite 5 in terms of fraction and we get 15 over 3 minus 5 minus x over 3 over 3. Now group the fractions together and after simplifying we get open bracket 10 plus x over 3 close bracket multiplied by 1 over 3. So that gives us 10 plus x over 9. If you found this tutorial helpful, please subscribe and stay tuned for more videos.